Day 807 off the grid, and today I'm actually doing some electronics. My hand's kind of been forced because yesterday the fridge started playing up, and in the end I traced the fault to a dicey PTC switch, which is basically a thermal relay. It's not really a PTC at all, because a PTC is something like a light bulb or something which increases its resistance with temperature. Well, this is more like a Curry effect switch, and it basically is a relay, but it drops out when it gets warm, so it's like a delayed off relay. You need them to start a fridge. Well, anyway, I pulled it apart, took it right apart, and found that the contacts were really burnt up. Gave them a clean, put them back in. Fridge is working nicely. However, I still suspect my relay switching box that I use with the fridge in order to run it, well, you know, I'm running a freezer as a fridge, so I've got this relay box which is connected to a fridge thermostat which I've installed in the freezer, and that's all done with low voltage. But the relay that I was using, I suspect, isn't quite up to task, and its contacts are becoming burnt up too, thus making the input voltage maybe not that great when the fridge is trying to start. Here's the original unit here. See, it's a nice neat die-cast box I made up. There's a 12 volt power supply in there. That was what this originally was. It came from Broadcasting New Zealand, but I just put a small relay in there, and that's where you just connect 12 volts across the switching contacts of the fridge thermostat. Right, so it works, and it still works, but I don't like the really kind of thin mains cable. That's like 3 amp cable going into it. I mean, that's enough to run the fridge. It's only 100 watts, but it may be limiting the starting current. So I've decided I'm going to make a better one, and today I'm going to use this. It's a 48 volt relay. It's almost a contactor really. It's got a coil of 48 volts DC, and it can switch, well, different ratings depending on how inductive your load is, but it can switch up to 30 amps at 230 volts AC, so that's the one for me. But of course I need 48 volts to switch it. Now what we're actually looking at here is something that I originally built in 2001, and originally it was a highly dicey converter that basically just rectified the mains. So you had the mains in here, went through the bridge rectifier, so we had DC mains basically, and filtered by this bank of fluorescent light capacitors. You had to feed it from a transformer, so A, it was isolated, and B, it wouldn't pull too much current when these were charging. But yeah, I used to run lights and stuff off DC because I thought it was better than AC, you know, easier on the eyes and all that, and I still believe that, but haven't played around with that much lately. A couple of years ago I converted this by rewiring it slightly into a nasty capacitive fed battery charger. So we've got the mains here coming in, goes through the capacitor, out of the capacitor, into the bridge, and then finally to these output terminals. Now the reason why I'm filming this is I'm about to tear this apart, because I just saw this in the shed before and thought that will be a nice case to house my relay and any other components I need to power it. And I never use this capacitive charger. It's well dicey. I had to flood the bridge with glue because you used to get these arcs and stuff there. It was really weird. But I wouldn't use it off the grid anyway. This was used back when we still actually had the grid. So I wouldn't plug this into any of my inverters. Hell no. So going to take it apart. Use the case. Caps will find use somewhere else. What you can use these caps for is wiring them across a circuit breaker or a relay that is switching high currents DC, and it'll save you contacts. Really good capacitors to use for that. You just rip them out of old fluorescent light fittings. Yeah, but anyway, I digress. I'm going to turn this camera off now. I didn't film any of the fridge or any of working on the PTC relay or whatever it's called, because I was kind of busy, just wanted the fridge going again. Really nice not to have to run out today and buy a brand new fridge. Yep, that's pretty cool, because I just spent all my money on a lovely 1800 watt Xantrix pure sine wave inverter off Trade Me, which I got for an absolute bargain. So now I've just got to wait for it to arrive. I'll show that in the coming days when I finally get it. it's going to run the fridge circuit. Well, here's the completed jobby before I case it up and take it inside and sort out the fridge, hopefully once and for all. There's our 48 volt relay. This is the switching side, that's the coil side. There is an HP printer power supply which has a 32 volt DC output and a 15. I'm only using the 32. 32 volts is adequate to nicely switch this 48 volt relay. It's about the lowest I would like to use. I normally prefer to switch relays at their rated voltage because you just want those contacts holding in really tight, but hey, this is a 30 amp relay. It's on a 10 amp main circuit running a 100 watt fridge, so I think we've got plenty of margin there. All the earth conductors come into this post here, which is also connected to frame. The neutrals are all joined up in this bit of heat shrink here, which is basically just a bit of sleeving. I did use some quick connect connectors for those as well. The line comes in here, goes to the relay of course, and a split off to the power supply. I actually soldered this onto the crimp terminal there because otherwise it was going to be too short if you tried to poke it in the top, so I crimped the yellow wire on which feeds the power supply, but I soldered this one to the side. Otherwise I would have had to solder on a tail and just, stupid. That was a good way around that, I thought. And of course the output from the relay just goes straight down here. This socket here is just a standard New Zealand main socket, but it's got like a cable strain relief here built in because I ripped this out of an old master slave switcher unit. In fact, it wasn't old, it was brand new. I blew it up the first time I used it because I plugged it into a modified square wave inverter and it instantly fried the Zener diode in the capacitively fed supply. That's why you don't use capacitively fed supplies with MSW inverters. I could fix it, but it's more useful to me to scrap, so I wanted this socket. So makes a neat job. You see, I just hacked out this here and it fits in there nicely and it's held securely. What else can I say about this? I mean, it's pretty basic. It's just a power supply running a relay switch through these terminals here. Oh, if I'd used a Euro connector at the back here to connect to it, it would have been too long to fit in the case, so I just simply, don't even see that in the light, I just simply soldered to the terminals, to the pins, you know. Works well enough. It's a good trick you can use if you're going to put something which is usually an external thing, putting it somewhere internal. What else can we say about it? No fuses. No fuses. I know that fuses are such a hot topic in the solar community at the moment. Well, yeah, I could have put a fuse, but I couldn't be fucked basically. Why? Well, for a start, there is a fuse inside here. This is fused internally, so that's taken care of. And this is a 10 amp mains lead going to a 10 amp mains lead, a 30 amp relay, and it's being fed off a 1500 watt inverter, which at 230 volts is barely even 5 amps. And of course it's fused and everything else is fused up the line, so no real need. I mean, there's a lot of things that'll blow up before any of this stuff will, so that's fine. With all that said and done, let's just give it a test. I've plugged this into the output so that when I bridge these two terminals together with this clip lead, of course the light will light up. There we go. How's that? If you can hear that hum in the background, that's the a step down transformer I've got here that steps down the voltage from the generator to run our 110 volt circuit, because it's shitty weather today, so it's been a generator day. We're after the equinox now, and it's really shit weather. So as you'd expect, yeah, this does that. Does exactly the same thing as the aluminium case box I showed you earlier. It's just that now we've got a really massive relay with huge contacts, the impulse current of a fridge motor starting is unlikely to burn this one up. So that's much better. Overkill, just the way I like it. On day 807 off the grid.